So now we're going to do some more factoring. Okay, we're going to build on what we already know, and we're going to throw in a few more, and then you're going to see layers of it. So it's not just one thing, but it's one part of factoring and another part of factoring and so on, okay? So a prime polynomial. Prime just means it doesn't break down. Like when we had prime numbers back in middle school, they don't break down to any other factors. It's just one and the number, okay? Same thing for prime polynomials. So prime polynomials are polynomials that do not factor. Okay? So there's no factors to them. You can't do your x and get any numbers. You can't do the box. You can't do anything. You can't do anything to it. That's prime when you cannot factor anything out, okay? Factored completely is pretty much what it says. It's kind of wordy in the book, so I'll kind of rephrase it. Factored completely means to factor out all GCFs and factor down any trinomials, binomials, etc. Like a polynomial, 4 terms, okay? So this is just saying to factor out everything you have. Again, we're going to layer this. So we might have a GCF, then we might have a binomial, we might have a trinomial. So there's layers. So to be completely factored, you've done all of the layers all the way down to its purest form, okay? So those are just some basic words. There's a couple more. All right, factor by grouping, that really just means the box. Okay, we've got 4 terms, so we put it in the box, and they call it grouping because they pair them up, but we pair them up too. So, a method of factoring 4 terms. Okay, so that's when we use our box, and we went from the inside out. That's another phrase for grouping, okay? Quadratic form is the form ax squared plus bx plus c, and in a couple classes, or maybe even next class, we're going to start adding equals 0 to the end, okay, because that's a quadratic equation. And so quadratic form or equation, okay, because I put the equals in there, is just that trinomial where you're starting with the highest exponent of 2, down to x, and then down from there, okay? So, let's just go through a little bit of just kind of the rules about factoring. Alright, so this says, a polynomial with 2 or more terms is a prime polynomial if it cannot be written as a product of polynomials, which means it just cannot break down. It's impossible. Anything you try does not work, okay? Of lesser degree using only one integer, coefficients, and constants, and if the only common factor of its terms are -1 and +1. Okay, so prime just means you cannot break it down. You can't do anything with it. It just sits there, and you thought about it, and there's nothing more to it, okay? So, example, 16x squared minus 4x plus 8 is not a prime polynomial because something is a common factor. So what is the GCF? They didn't write greatest, but what's the GCF of 16x squared, 4x, and 8? And in this case, it's just a 4 because not all of them have an x. Okay, so 4 is the GCF. A polynomial is factored completely if it is written as a monomial or the product of a monomial and one or more prime polynomials. And all that means is when you factor it down, you can't take those answers and factor them more. You just have to stop. Once you hit a bottom and it won't factor anymore, that's those prime factors that you get at the very bottom, okay? So here's an example. It's x plus 2 times x squared minus 5x plus 6 is not factored completely because this will actually factor a little bit more. If we take that and make our x with it, okay, positive 6 goes on top, negative 5 goes on bottom. So the factor pairs of 6 are 2 and 3, but 2 plus 3 adds to positive 5. So let me make that a negative 2 and a negative 3. So this just factored. I was able to find two numbers that multiply to 6 and add to negative 5. So the factors would be x minus 2 and x minus 3. You take that factor pair that you found and you put it, and so now it'll factor more. And then these don't factor. There's no squared. Even though they are binomials, it doesn't follow any patterns of binomials, okay? So that is just kind of some of the basic definitions of polynomials. And so we'll flip to the next page and we'll add a few more patterns to our flow chart. Well, it'll go into our flow chart eventually, but it's just more patterns to recognize to apply in factoring, okay?